No, that was your copy pasted twice. It was for Sumit.
Also.
Ah.
So, good evening, everyone. We have Nagashree Jay. She's our MTech Artificial Intelligence student. She is doing her Capstone 1 on the topic AI powered damage assessment for apparel returns. Now we will have 20 minutes for the presentation and the demo, and then 5 to 10 minutes of Q&A. After 15 minutes, a warning buzzer will ring, and then we'll have 5 minutes to wind up. All the best, ma'am. Thank you.
Good evening, everyone. My name is Nagashri. I'm part of AI07 batch, studying MTech in Artificial Intelligence at REVA University. I currently work with Target with overall of 10 years of experience. Yeah. Yeah.
When you said 10 years, I thought you were just 3-4 years.
Yeah. And yeah, I'm a software developer. Today, I'll be presenting on my Capstone Project 1, titled as AI-powered damage assessment for apparel returns. Let me tell you why I have selected this topic. Since I'm working with Target is a US-based retail company. In my tenure, I found that there are multiple challenges we are faced, but returns is the one which has a major revenue impact. That is why I have selected this topic. Okay. Coming to the agenda, I'll be walking through all this topic in detail. E-commerce made shopping easy and convenient. So imagine a customer received a trending shirt, ordered online today, ordered online, but upon opening the package, they found that shirt is torn. Okay. Think about multiple customer returning the items. Multiple customer returning the items, then the apparel. In fact, the apparel is the most returned product category, which is leading to 26% of, which is leading to the 24% contribution. And also, like the major reason for the return is damage. Okay, and coming to the retail, manual inspection is time consuming and challenging. Someone has to manually inspect the items and determine whether the item is really damaged or not. And also, like sometimes the loyal customer often face refund denials, and others claim false returns, like frauds. Okay, so to support my project, I have referred following papers and found that YOLO and CNN, RCNN was the most commonly used models. And whereas RCNN provides accuracy but suffers speed, whereas YOLO is faster. YOLO is faster and provides real-time speed, which is best for our e-commerce. And yeah, so some of the studies were trained on the lab data set, and this doesn't work for the real data set. And also, I referred few paper which just spoke about filter and augmentation for feature learning, to improve the future learning. And also, coming to the problem statement. Sorry, coming to the challenges. When a guest returns an item, the items doesn't go to the shelf directly. The items are returned by guest. They generate a label, paste it on the box package, and this will be sent to the CRC. Sorry. Okay. So the customer returns the item, generates a label, adds on the package, and send it to the courier. And the courier service will be sending this item to the warehouse. And in the warehouse, the item will be inspected for the damage for the specific defect types. And then they will send it to the finance to inspect whether to the finance for the refund.
And takes 7 to 30 days.
Yeah, this takes 7 to 30 days. And coming to the inspection, manual inspection, this is error prone and slow and inconsistent because they have to find the exact defect and they have to do the refund. During peak, the inspection may be slowed down due to the high volume returns. Even though item is refund, even though the finance team refunds, the payment system takes another 7 days due to the process, bank process. And also sometimes what happens is fraud tries to return the items, saying that damage, but actually there is no damage. And this is costing for the company, because whenever it is a no damage, whenever it is a damage, we have to refund the shipping charges as well. So which will be around like $2.99 to $9.99, which is the shipping charges. Coming to my objectives, the first objective is to standardize the data collection, annotate the apparel damages, and develop the scale. The second one is to develop a scalable AI solution using computer vision to classify different damage levels for the apparel. And the third one is to develop and deliver AI solution that can be integrated with e-commerce return workflows. Yeah, coming to the methodology, have followed the TDSP approach. So the first starting point for the TDSP is the business understanding. Here we found that the items which are returned by the guest takes like 10 to 30 days to get the refund. And also this is not the cost effective. And also there is a operation cost involved. And also the guest is frustrated because of the delay in the refunds. And also last year I did the data migration data migration on the images uploaded by the guest. So the data was migrated from Google Cloud to Amazon Cloud. So when doing this migration, I found that these images were not used in the real time. That is how I got this problem. And yeah, on the data acquisition, I've all this data I've retrieved and cleaned and annotated using RoboFlow.
Where is this image coming?
Sir,
Image. You said some image, right?
yeah.
Where is this image?
So whenever, yeah, it's fine.
Customer uploaded.
Yeah. So when
Customer take a photograph, damage, but now you will upload it.
yes.
Or no, customer will upload the image, then they send the refund.
So whenever guest is returning an item, they upload the damaged image, and also they will send.
It's interesting. So there is no image uploaded by the quality control in warehouse.
No, they have not done it.
No, customer will do it. So only one image. No, even the. So and the another thing is you said shipping charges.
Yeah, shipping charge. Yeah.
So the customer has to ship it back.
Yes.
Not the.
What that means is, if it is a damage, it is considered as a company technical issue. So in that case, whatever shipping charge for returning, that will be not claimed on the guest. It will be claimed on the company.
So how we return, right?
Yeah.
That's a Amazon. Free return. It's a free return for the customer.
Yeah. If it is a damage, it is a free return. If it is other like chain mind or other reasons, then we charge the shipping charges. Means we will not do the full refund.
Okay.
Instead of if the item total is $10 and shipping charge is $2, we will only give back the $10. We will not give the $2 if the reason is the chain mind. If it is damaged, then we will refund $12. That is why
One effect in the process is that the quality control doesn't take a photograph. For example, let's understand. This is a glass. I take a photograph and send it. And for example, customer doesn't understand this picture will be in yellow or this will go for any past and this and it. Now in the system, the defective image is there. Quality control has seen it. Yeah. And there is a defect. Quality control never uploads another image.
So what is happening is,
do you get the question?
Yeah. What is happening is, when guests upload an image during the return, that images are not used real time. Only for auditing in the later stages, it will be used. Oh, that is like a documentary. Yeah, yes.
That's my curiosity. No, yeah. Just using, you send it. Forget about the pictures. It's like a document, like a rubber stamp, but we get earlier in the airport.
Yeah, that is not used real time. No inspection is done on the real time.
Like a Zomato food order. If you say food is damaged, you get 30%. Then who's looking at the image? Because you have uploaded the image, that's a first product.
It is like a fuzzy logic. They have some rules. Based on that rules, they just do the refund.
If customer has uploaded 3 photographs, is good.
Yeah. Yes. And that is also based on the reason they have selected. As I called out damage, there are several reasons for it. If it is a damage, we will refund the shipping charges. If it is not damage and it is a chain mind and other reasons, they have other reasons like size and all, then we will not refund the shipping charges.
But
So yeah, we spoke about the business understanding. Also, we talked about the data collection. Now coming to the feature engineering. For better understanding data, we have augmented the data to learn the features properly. And coming to the model, we have trained on multiple models and evaluated on metrics. And then this is deployed on the Gradio for testing.
What is Gradio?
Gradio is a UI interface, which is
Yours, custom.
yeah, just for demo I'm using.
Okay.
And I've built an API also. I'll just go through that in the future slides.
that's your target one. The great-
No, this is for demo I'm using. This is
No,
not.
so Gradio is something which is a target product, is it?
No.
What is it, a Gradio? It's a commercial product.
Yeah, it is a cloud-based UI.
Oh, but for package, is the package.
No, it's a UI. For just showing demo, I've used it.
Oh, Gradio, I don't know. Okay.
Yeah.
Instead of stream.
This is from the Hugging Face.
Oh, it's Gradio is part of the Happy.
Yeah.
Okay, that's right. You use Streamlit, so I was okay.
I thought like everybody is using Streamlit even.
Streamlit, yeah, I've tried Gradio just for the change.
Okay, then. It's a better interface. Let's see how it looks.
Yeah.
Carry on.
Yes, sure. And yeah, to develop a robust system, I have used following specification. I've used my local system to retrieve the images from the cloud, and also I've used the cloud compute instance for training and documentation. And following component is used for supporting my training and augmentation. Coming to the software design, the data are extracted from the cloud in the batches, and these are annotated using RoboFlow. And then it is sent for the pre-processing. In the pre-processing, we have filtered the data, resized and augmented to augmented and then standardized to YOLO V8 format. Coming to the feature engineering and balancing, for the rare classes, we have augmented the image to balance the data per class. And coming to the model training, the YOLO V8 is fine-tuned on the curated dataset through transfer learning and retraining multiple times. This one I'll be explaining in detail in the next slide. And this trained data are validated using evaluation metrics such as MAP, precision, MAP, precision, recall, confusion metrics. And this is deployed on the Gradio for testing.
F1 score.
Yes. I've used F1 score also. I've used multiple metrics to detect what is the accuracy of my model. Yeah, coming to the sequence diagram, it is a flow diagram to show the data flow between multiple components. Starting with the user uploads this written images, and those written images are there in the cloud, Amazon cloud. We retrieve that through API and then send it for the annotation.
No, she can do it.
Can you zoom it more now?
I can zoom it a little more.
It's a touch screen, no?
No.
Touch, can you touch?
No, it just.
Oh, no.
Okay, reduce a little bit, otherwise she'll not be able to see that.
It's fine. I can. You can zoom it first part and then I can go with the second.
Okay.
That's also fine.
That's okay, go ahead.
Yeah. So we have multiple components: user, e-commerce, data annotation, pre-processing, feature engineering, training, evaluation, and interface for the using Gradio, and then the platform where this API will be deployed, integrated. So I'll just walk through the sequence diagram. So the guest submitted written images are retrieved from the cloud, and then they are sent for annotation, and they are labeled into 5 classes. And this labeled images are sent for pre-processing, cleaning, resizing, normalization, which will be discussed in later stages, why I'm doing all these things. And coming to the feature engineering, I'll analyze for the class imbalance and augment based on the rate for the rare classes, and then trigger relabeling based on the accuracy. And coming to the model training, we load the pre-trained YOLO models, different YOLO models, and fine-tune those on the our data set, defect data set, and then take the weights and validate on the validation data sets. And then we calculate the precision recall map, and if required, we retrain multiple times to get the better accuracy. Once we get the better accuracy, we have run the interface in inference with the YOLO V8, and this is uploaded in the Gradio, and user can see the bounding box and defect labels. In this case, the user is the company user who is testing this product.
One quick question: how is the annotations happening manual?
Yes.
So who does the annotation?
Yeah, I have done. So for my project, I have done.
Oh.
If for the large data set, there is like in
The BPO team is there to
yeah, yes,
okay.
there is a bigger team.
A BPO team, I was saying, check your image, they will name it now.
Yeah, there is automated script also in the Romo flow, which
Okay.
we have to pay.
Okay.
And also in our company, we have a few people to automate also
Okay.
that process. Coming to the implementation, the first thing is the data injection. So we retrieve the data from the API calls. And second is annotate using the RoboFlow. And third, check for the class distribution. So the annotation is done based on following pictures. If you see, the first picture is about the stain. The second is tone, zipper, hole, and no damage. The exact location, we have added a bounding box with the stain, tone, zipper, hole, and no damage. And once this was annotated, we have analyzed for the data class distribution. So the class distribution vary from 200 to 500. 250 is the least, which is for the hole, and the highest is for the stain. And we have done the feature engineering and balancing. Can I go to the next slide?
What have you done with the balance?
So balancing, I've used augmentation for the rare classes such as hole to increase the number of count for that classes. So this is the augmentation script I've used. I've added some brightness, noise, crop, rotation, flip, etc. to add more images. So here is the original image and the augmented image. We have augmented using the brightness. And this data set is split into train, validation, and test. And also, if required, we have relabeled the images based on the accuracy. Sometimes what happens is we have sometimes have label while labeling, the bounding was not too close to the tone or stain. It was far away, and the model was not learning properly. So I kept it very close. That was done during the relabeling. Coming to the model training, evaluation, and deployment. During the model training, I've used the basic to advanced YOLO models such as small, medium, and large. And I've used the pre-trained weights, which is YOLO V8 PT. And then I've used Epoch. I've started with the Epoch 200 with patient 20. This is for early stopping. Whenever the model is not learning, I'll be stopping the model. And again, I'll just see that labeling and everything is correct. And then I start the model training. And this mod, and also I've resized the image to 640 because whatever the image guest is uploading, it won't be like 640 size only. Some people may use premium mobiles and some people may use the basic models, basic mobiles. That time the size of the images will vary from 640 to 1000 pixel, 2000 pixel. That's why I've done this resizing. And then I've used the batch 32. Any questions?
No, we'll ask later. Otherwise, we'll slow you down.
So coming to the validation and testing, this data are loaded and validated for corrupted files using the script. And then it is annotated using the YOLO V4, and we check whether it is properly validated, and this is done manually. And then comes the pre-processing and augmentation. In the augmentation, we balance the sample count per class. For example, for all we had 250 sample, now I've increased to 350. This is an example, 350 to 400. And train validation split, have used 80-20 split. And model training pipeline, I've trained the model and checked for the F1 square confusion matrix and precision and recall curve. These are my metrics which I have evaluated. And sometimes what was happening is for no damage and stain, the model was not learning. Then sometimes the designs were considered as stain, and sometimes the stain was considered as design. For that, what I did is I took my model, the custom model, and trained with. I did the transfer learning by freezing some of the layers, and then I made it to learn only no damage and stain. By this, we have increased the accuracy of our model, and have evaluated the model with the following metrics: confusion matrix, PR curve, F1 curve, MAP at 50, which is a mean average precision. And this is deployed on Gradio Cloud for testing purpose. And the accuracy, and we get the API response less than 10 seconds. Coming to the performance and accuracy checks, for each label, we have achieved 91%, like 0.91 precision, recall 89, and F1 score around like 96, and MAP around overall 0.90. So for stain, it was like 70 because the no damage designs and the stain was considered as the same issue. That's why the recall was around 0.70. And here is an example where the model has detected a hole with confidence score 90 or 0.9 and stain with 0.7. So we have trained to detect this all the classes using following models: small, medium, large. And also I have compared this with some of the VLMs like SAM, Cloud, and Gemini. And my model has performed 90% accuracy for old tone and zipper, and for stain it was around like 70%, 70 to 80%, and the response time of the inference was less than 10 seconds. And this is the performance of the cloud, which was like it was detecting, but it was going somewhere else. And this is the performance of the Gemini, which was detecting and it was not overlooking on the exact stain.
So you used API or directly uploaded the image? For Gemini, you used API or?
Yes. Yeah, both are through the API. So you can see like Claude could not locate the stain. It's located somewhere else, and also Gemini located somewhere else. But our model, it gave a stain with 0.7%.
In comparison, use someone said let's use LLM, see what happens. Yeah.
And this is also custom model which I tried to train for my data set, and this was 0.4, and small is for less than 1,000 data, and for large is for more than 5,000 data, and medium is for less than 5,000. Yeah, coming to the demo. This is my UI just for the testing. And
This is Gradio, what you're saying?
yes. This is the home page. So I'm just uploading the guest uploaded images. We can see that there are multiple holes. So it is able to detect the multiple holes with confidence score 78 and 84.
Let's give a recommendation, refund, not refund. It doesn't give anything like that.
This system will not give, but we have to integrate with the refund system.
Yeah.
And I'll upload one more.
Can you upload a dark image
Image.
with less lighting? Oh, you can't see the image also. Okay.
So in the annotated image, you're increasing the brightness and other things.
Yes,
right?
yes. Because the real data will not be like, would,
So, but when you
we'll have some noise also,
so
that's why.
do you brighten all the incoming images pre-processing to brighten it?
During training, yes.
No, when you are getting the real
No,
RGB.
No. It is trained on all different data sets, so it will be able to detect. So only during the training, I've done the augmentation so that the model learns better. So there is a whole and tone stain. There is a whole and tone on this image, and with 92% it is telling it is a tone, and telling whole with 71%.
That's a confidence level.
Yes, with this much confidence, it's able to tell that it is a tone and it is a whole. I'll try for some zipper. So this is an example for zipper. With 89%, it is telling it is a zipper.
What are the different categories of defects in apparel?
So I have considered only the 5 labels.
And how many are there total? If you do a classification.
More than 10. There are like loose threads and fabric, bad fabric.
Second, do you also integrate the text with the user is typing?
Yeah, that is my next project.
Oh, it is there, okay.
Yeah, next project.
Oh,
I'm
the
working
Capstones too. So you take the text and do it. Okay. You're also can you just go back? What is the balance where you have lesser balance and you created the more? Can you just go back? Which one? I think stain was 0, completely 0. How come stain is not there at all? Stain, there was no.
Actually showing in this system, but
Oh, okay. Like gray. It is gray. Oh, yeah. The first thing, okay.
No, it is visible.
I thought it's not there. Sorry for that. So, in practical, what is the biggest thing they actually complain? Stain is the biggest.
Stain is the biggest issue.
Okay.
If you see it from this side, it looks.
Yeah.
Yeah, there is this stain portion. So stain is coming as the highest number of complaints, is it?
Yeah. As per the image collected, it was the highest one.
Mm.
And let me tell you the challenges during the data collection also. So during data collection, it was not pretty easy for me because the images were uploaded in S3 bucket, but written comments was in the different system.
Okay. How much?
Yeah. Then I need to find the written comment, and also I need to find what is the category of the item. If it is an apparel, take the written comments, check for this 5 categories like stain, tone, and all.
So I'm sorry. So your image is stored in one system?
Yeah, in one system, and it's written comments is stored in different system. And also the item for that order is stored in different system. So I need to.
How is that? It's not integrated.
It is integrated, but whatever the store data I'm using, it is from the big data. So when it goes to the big data, the images will be stored somewhere else, and they will give the reference only. And it will be reference for the order number. It won't be reference with the written comments and all. So you have to check for.
Everything will be reference number as order number only, right?
Yeah, order number, but it will be having the subtables, no? The order number, and it will have a subtable for the return orders. So it was little complex to collect the data. Actually telling it is more complex also because the attachment ID, I have attachment ID, but I don't know whether it is an apparel or not. I don't know whether it is a damage or not. So I need to check in the database and filter for the category like apparel, and then take the written comments, filter for the defect types for the 5 categories, and then take the attachment ID, download the images from the cloud. This was a process I followed.
Surprising, but yeah.
There is no defect severity, is there? You send the defect severity scores?
Not to the guest, but to the refund system.
For example, there can be a hole with less severity and high severity. All holes get replaced, or there is a policy first?
Yeah, whatever the defect is, we have to do the refund.
So there is nothing called a high severity score, low severity score.
This is during the returns, that is why. And when we go with the other types, like when we go with the perishable items, then we can't ask guests to return the item. It has to
This
be,
is for apparel. Now. This
yeah, this is
apparel.
apparel, yeah.
But there will be other things for footwear. And
Yeah,
other
there are,
things.
yeah, several reasons, and based on that, we
So
do
that you can also expand.
yes, yes, yes. And one more thing I wanted to show in the demo.
During the YOLO thing, any misclassification happened?
Yes, for
Can you show
state,
some of
yeah,
the show?
confusion
Matrix, yeah.
yeah.
Can you show the data also?
Yes.
Yeah, one is here and then actual file also.
So here it explains like a total there were more than 90 sample, out of which 68 was detected properly, but 10 was miscalified.
Do you have
Like-
that image where it was misclassified?
It is in the cloud.
Okay.
I need to connect to that.
Okay, so what was the reason for misclassification? Like lighting or what they were saying that?
Because of the design. In the no damage, we have some flower design, and stain also we have some design. Means that stain. When they both are compared, it looks same only. That's why it was misclassified.
So then what happens? They don't refund it.
So we have to improve in the coming project. That is my feature enhancement, which I'll be talking
What is
about.
what is your overall accuracy?
So the general accuracy is 90%. So for stain it is 70%, and for all it is 96%. So yeah, I have measured with mean average precision at 0.5 is the IOU, intersection on union. So when there is a box and it whatever the grounding truth, it whatever I am detecting, it is how much it is intersecting. That is the IOU. At 0.5, it is like 90%.
Okay. What is the F1 score then?
Can I use the board? I can.
Yeah.
There is a stain. This is the image.
It's called overlap. You're saying intersection. Okay.
Yeah.
Overlap intersection.
Yeah, this is the grounding.
Yeah.
So when I train my model, the accuracy is coming around 70 to 90% based on the class level. This is because the model detects like this at 0.5. This is a 0.5, like overlapping is 0.5. So this is my model detecting, and this is the actual one, but it is detecting, but very close, not exactly.
Okay. Sorry.
But still it detects.
Yeah.
And as I called out for stain, because of the flowers and all, it is not able to recognize.
Stain is like
Yeah.
color thing.
Design also. No?
Design and color, everything
Yes.
will come into it.
For every image that you have taken, you have augmented with the different angles
Yes.
for every image. So one is that, so you balanced.
Yes.
One is balancing.
Yeah.
Balancing would have it. But for example, on what basis you decided on? Because it might be that the same image would have different types, but you don't know what variations are. What do you do for augmenting different angles?
So for the less instances, only I have less instances means the class with less numbers. For that only I have augmented. For stain and all, I have not augmented.
How do you know that those are not of the same type images?
So while labeling, I have done the manual labeling. That time I have.
You see different angles, different views.
Yes. So I've noted down everything because I was labeling from like 1 month. Like I started for 1 month.
How many training set?
1,500.
And what is the segment? The count was you already said that volume that you had created. How many you created augmented?
So augmented, let me go to that. This was before before augmentation. This is after augmentation.
What's the change?
Yeah. For all it was around like 250, but I've increased to 400 because I did not have less. I did not have more instances, and no damage was okay. And tone also for zipper also I had very less instances. I've augmented it.
Even for the stain also you haven't added too many.
No. I just
The only thing that you added is hole and
for
tone.
hole. And for this I have added only for few data sets. I've added, but it is very less.
So will this be going to production or they what?
Yes, it will be going, but we have to add more labels and also add the
So it will be part of the return process itself.
Yes.
Okay.
So
at enterprise level.
Yeah. So now it is a basic model prototype. For production, we have to train on a large number of data.
It will be part of the target.
Yes.
Okay.
Yes.
And then you need the computation.
Yeah, competition is the main one.
That we are talking.
So for training, we would need GPU only with 32 GB like that. So when I try to use that much, it will be not feasible for me. But for enterprise, it is feasible.
Okay. See this image, the right side, it can, I mean, how do you detect, what is the accuracy of this detection? It's a stain or it's a hole?
So it's with 90% confidence it is saying it is a hole.
On the right side image.
Yeah, with 77% it is saying that it is a stain. It's a 77%.
But the stain is smaller and it's in a darker
Yeah.
shade, it might
Yeah.
misclassify as a.
Sometimes what happens if the design is black color, some round design if you have with a black color and stain is also black color, it may misclassify. Even that will be classified as stain, or even this will be considered as design. So we have to add more data set to train this, to overcome this kind of problems.
Okay.
And also,
What I think did not work out when you're doing this, because again, if you look at it, you use yellow, looks everything is, but what are things did not work out? You have to again revisit and redo.
for labeling, I gave the bounding box little far away from the tone. The model was not learning at that time. I have to revisit, relabel, keep it very close so that the model learns it. This was one of the
Can you
challenges.
get this? I think I missed it.
With the bounding box we have created,
right.
it was not too close to the defect.
Okay.
So again, I relabeled, kept it very close so that model can learn it. I kept it like.
Oh, it's a big
yeah,
box with
big
you.
box.
Okay, okay.
Yeah.
Okay.
So
The
it was-
boundary.
So because when I think the model splits that within the bounding box itself, it splits it to pixel and then it learns, right?
Yeah, these are the features for it. Every pixel is a feature for it.
Correct, it learns
Yeah,
that
script
way.
and all it creates and it learns from that. Since I was giving a bigger box, it was not able to learn. And also I'll show demo on API build. API build. So this is the API build.
So you spoke about RCNN in between somewhere. Where have you used that?
So RCM is for the large data, and it provides good accuracy, but suffers for the real time images.
The latency.
Yeah, latency. Like it may take like more than 10 seconds, but for the real time problem, it is faster. It is faster, and if you go with small and medium, it is very faster. It is less than 10 seconds.
Why did you not use SAM? Did you try SAM?
Yeah,
We were discussing SAM in the last.
yeah, I tried SAM.
Okay, what's the performance of SAM test?
Yes,
It's not as good as yellow because
Yes.
of the efficiency. Sir.
yeah, efficiency, and you have to provide the prompt.
Ah.
So you have to provide the prompt saying that in the corner there is a stain you have to locate. Then only it used to locate.
Or directly from the images, it was not.
Not locating. So this is the API I built. So with the image, when we make a API call, it gives the bounding box with the confidence score and the label as old. And the confidence is 70%.
And you're going to add up the customer comment and give you add it up together.
Yes,
What
yes,
customer-
that is the next project of mine. And this API can be integrated with the refund
So this
system.
can go for full production in Target. They have
Yes.
approved it also.
Yes, it has to be trained
So
on
you
the
want
large
to share
data.
with your boss?
Yeah.
We are very happy.
With my manager, yes.
Okay. So what's the name of this solution that you're going to deploy at Target?
So this will be AI inspection only.
Oh, there's no name like
Yeah.
Genie name or Gemini. Or...
So it has to go through the scoping process and then it will come for the development.
Okay.
Yeah.
They have
Yeah.
in the process of
Yes.
identifying and
It takes around like 6 to 1 year for this to be productized.
I mean, approval itself will take around 6 to 8 months, right?
Correct. So first is manager and then their director, VP, everyone has to go through this project.
Where you have understood your manager and love it.
Yes.
Yeah, okay. I just wanted to see what's the UI for the new interface that you have done. How it is different from Streamlit? Why did you use it? Just asking. Because you had it for Hugging Face, that's why you.
Since I told it I need to deploy in the cloud and Gradio is a cloud-based application,
yeah.
so I've used the Gradio.
Okay.
What cloud service do you use? AWS, is it?
No, for this one,
No, not this.
so coming to that point, we use Google Cloud, Amazon S3 bucket. We use many things there. Based on the application and based on the confidentiality, if it is more confidential, we go with Google Cloud. And if it is like okay, medium time confidential, then we go with Amazon. Because the images, whatever we have used, that is not more confident one. So we use, that's why it is stored in the S3 bucket. And it is it is managed by infrastructure team. And that one is not managed. Google Cloud is managed from the team itself. Whoever is using, they have to manage their cloud.
Let me confirm, all the images that are captured is from the customer, not from the quality team.
No.
So it is the customer. So in other
Yes.
words, your behavior is already
Yes.
captured.
And also, if you can see all the images which I have shown, I'm just taking only the apparel part. I'm not taking any face or anything.
Right.
While uploading, the guest will upload the face also.
So what do you?
So while taking images, I've removed that images for the compliance issue. That's why the size of the images are like 1500 for
So
the.
when you do the real analysis,
Yeah, that time it will be in our system only, so we don't have to worry.
okay.
This is
crop things and
yes.
that balancing act.
Yeah, we can do cropping or we can use it directly because of our enterprise cloud. Here I have used the external
You
cloud.
mentioned about 26% is the return rate, or 26% is what?
Apparel returns.
So if every 100 apples that are shipped, 26%.
26 are returned.
Very high. Okay, I didn't know. Myntra would be here.
Myntra is much more higher.
Yeah.
For size, when this help you, you can't do anything for size. Only for defects you can do.
Yeah, for now,
size,
yeah.
apparel, you said apparel.
Damages.
Damages, not for size. Size you can't test.
So see, their problem is if it is damaged, they'll have to process the shipping charges. If it is
You just share
I have done something, all those things if it is from my side, they will not process the return charge.
Yeah. Correct.
So the return charge, this will
Shipping
help
charges.
them in saving the return charge. That's
Yeah,
what
yes.
it is.
And also what
Cost implication.
yeah, one more thing is customer frustration. They have to wait for 10 to 90 days, 10 to 30 days because of the inspections, slowness in the inspection.
So this will be real time, isn't it? Once they upload, it will be processed and
Yeah.
It will be done within 3 to 4
Yeah,
days.
we can provide the gift card
immediately.
as a refund.
Because just upload and you check immediately. Within
And
2 minutes.
if you provide gift
Not
card,
only that,
You will go to human
in
interface.
that process it is okay, but the finance team has to approve it, right? So that will take 2
Oh, they'll get the AI, then they have to see.
so when the finance team also will approve. If the inspection is correct and they tell that it has to be refunded, finance team will
inspection what? AI inspection or?
yeah, inspection.
Then?
And if in future we can also have the feedback loop, which I'll be discussing in the suggestion and future enhancement. But coming to this point, where the finance team will be doing the refund, that time whenever system says that to refund, then the finance system also will do the refund. And in the auditing,
So there's no human in the loop.
yeah, in the auditing,
Only for high value items. Or only for high value items. So in the workflow for
this is what it will be more.
No, even for example, for high like some branded clothes, like $300, there might be a person or low value clothes, they might approve.
Yeah, $300 they may approve it, and also we have chargeback.
Okay.
So when this item really goes to the manual inspection, they can check and see like if it is not correct, then they will charge back in the next order.
How do you capture that as a feedback? In case a chargeback happens.
Yeah.
How do you capture that, because the model has misread it?
Yeah, this data is collected in database, and we have to
So
add
you have a separate chargeback database?
Yes.
Okay.
So in the multi-model, we have to integrate with everything. One is the written comment. Second thing is the images. Third thing is the purchase history. And purchase history will have the chargeback as well. So from that, we will get to know and we will charge in the next. Like next return will be like old, or whether we have to hold it or we have to refund, that will be decided.
Okay, thank you.
Coming to the conclusion.
Conclusion. We have taken up.
See, again, we did the same thing.
Interesting conversation.
Coming to the conclusion, we have detected 4 apparel defect types, which were tone, hole, stain, and zipper, and with no damage as well. And we have achieved MAP at 1.5, like 90%. High accuracy and recall was observed during our training and validation. And also, the YOLO V8 medium model best fits for this use case with high speed and precision, and this is ready for scaling. Coming to the future enhancement, we have to add more stain examples so that we can improve the recall value and use the written comments. It will be extra layer of check. And we have to enable multi-model because we can add the purchase history, written comments, and also image. And make a decision whether to refund immediately or hold the refund or ask the guest to talk to the agent, I mean the customer care. And we have only 5 categories, and we can increase to different categories, which I told, like thread, loose thread, bad fabric, and there are like n number of reasons. We can add samples for that and train the model. And we have to enable the user feedback learning also. Like whenever the inspection sees that there is no hole or something, then they can send the feedback saying that there is no hole, and the machine will learn from that examples. Yeah, these are the paper I have prepared. For the report, we have achieved like 7% similarity index. And this is the GitHub link where the project is uploaded. Thank you.
Thanks, Atal.
Good one.
Thank you.
Thank you. We have asked as many questions as we wanted to, so it's okay.
Thank you.
Okay. Last one.